right, we're back again. Absolute value, all of our function families. This is going to be part 2. So this is where we get a little more in depth with absolute value rather than just the basic absolute value. So the general equation for absolute value is y equals the absolute value of x minus a plus b. Remember when we did yesterday, it is a v. And it talked about the vertex, and I said we're going to talk about that a little more in depth, and that's AB. Okay, so the vertex is AB, and we're going to talk a little bit about this. All right, so number 1, I have the equation y equals the absolute value of x. And I'm going to do a little graph. It's not going to be anything fancy, but I want to show you some things about absolute value. Just like we did with linear, sometimes you don't have to plug in the numbers to be able to graph it. For instance, right here, I can take, just like the coefficient on the x with the linear, you have the same coefficient on the x with absolute value. So in front of here, if you can't see it, it's kind of the ghostly Gladys 1 I would talk about, that is the slope. So the slope is this time 1. Now, if I have to make it a fraction, of course, I can put a 1 under it. So that means I'm going to rise 1 and I'm going to run 1. Now, the vertex for this one starts at 0, 0. And we're going to talk about vertex here eventually. And we could actually even graph these a little bit on our graphing calculator too, but I'm going to show you this, okay? So the vertex is 0, 0, and you're going to do the slope. Now, slope would be up 1 over 1, up 1 over 1, up 1 over 1, but you know it has a reflective property, so it does the same thing on the other side. Up 1, back 1, up 1, back 1, up 1, back 1. So this looks like that. It's a V, and the vertex was 0, 0. The slope was 1. So here we go, number 2. Actually, you know what? I think I can put number 2 over here and save us some room so we can kind of see all of this together. Number 2 would be y equals the absolute value of 5x. Now, think about what we learned yesterday or a couple days ago with linear. The bigger the slope, what did we notice about the line? And hopefully you're saying it's steeper. Well, guess what happens with absolute value? That same characteristic is true. So this time, here's my slope. My slope is 5. And so if I make it a fraction, it'd be 5 over 1. So now I'm going to rise 5 and run 1. Again, we're going to talk about vertex in a second, but the vertex right here starts at 0, 0. So now you're going to go up 5 over 1. 1, 2, 3, 4, 5 over 1. And then it's reflective. Now I could keep going. 1, 2, 3, 4, 5 over 1. Actually, it's way up here off my sheet. There we go. So here, same thing. You're going to go up 1, 2, 3, 4, 5, back 1. Up 1, 2, 3, 4, 5, back 1. So, oops. As you can see, and again, I would use a straight edge. I just don't have one with me right now. You have an extremely steep line or a steep V. Okay, so that same characteristic is true. All right, so now let's do 3. Let's do 3. So 3 is y equals absolute value of 0.2x. Now, think about what we talked about with characteristics of lines. This is actually 0.2. You should know the fraction for 0.2. Do you know it? This is your slope. And so now your slope is 0.2, which is the fraction, hopefully somebody's saying it out there, 1/5. So now I'm going to rise 1 and I'm going to run 5. And when I had a fractional slope or a very small slope, what did we notice about our line? It wasn't as steep. Same thing happens here. Again, my vertex is 0, 0. So I'm going to start here. Now I rise 1 and I run 1, 2, 3, 4, 5. I rise 1 and 1, 2, 3, 4, 5, all the way over here. Same thing here. Up 1 because it's got a reflective property. And now I go back 5. 1, 2, 3, 4, 5. And it's going to be over here. All right, so my line this time for my absolute value is really wide. It's less steep. It's almost a horizontal line. But again, it's still a V. It's still absolute value, and you can tell it's got an absolute value sign. Okay, so now we're going to talk about this business of the characteristics with the vertex. So this one, we have f of x equals absolute value of x plus 2, and now you're going to do minus 3. So if we were to put this into our calculator to see what it's like, it's going to give you the vertex of, what do you think? Well, according to this, if you look, let me highlight here. Well, we'll start with orange. Here, it says the vertex A is the number found inside, and it's a negative A. Now, the vertex B, let's do this blue, is here, and it's outside the absolute value signs. So if I go back to vertex, inside the absolute value signs, what's here? Nothing. It's 0. Nothing after the x. What's outside? Whoops. No. Oops. Let's do what's outside the absolute value. Nothing. And guess what my vertex was? 0, 0. So my vertex here was 0. My vertex here was 0. Let's go to this one. Here was my equation. A is inside. What's inside right here? Nothing. It's 0. What is outside the absolute value? Because that's where it shows up, outside the absolute value. What's here? Nothing. So it's 0. So again, my vertex ended up being 0, 0. Just like here, my vertex ended up being 0, 0. One more time, inside the A. Anything in here after the X? Nope. 0. So here's my 0. And outside, anything here? Nope. 0. So 0. All right, so those are all my vertexes. Now, let's look at here. So inside is the A. So it looks like my vertex would be 2. But notice the equation says that it is a negative A. So because the equation is a negative A, that means whatever is in here, I'm going to times it by a negative 1 because it says negative A. So 2 times negative 1 is negative 2. So if I put, let me write vertex here. And then outside, right here, this is it, outside, I just have a negative 3. And notice this says plus B in the general equation. So I can just take whatever it is, and it's negative 3. So my vertex is negative 2, negative 3. So that's where I'm going to start. Negative 2, negative 1, 2, 3 is my vertex. Now, my slope is right here. I think I did that in green. It's the coefficient on the x term, and my slope is 1. So that means I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and then I'm going to go up 1, back 1, up 1, back 1, up 1, back 1 to here. So my slope is a 1. My absolute value graph is a V. And my vertex is -2, the vertex where they meet, -2, -3. All right, let's just do a couple more. So number 5. Number 5 is y equals absolute value of x minus 1 plus 5. So according to here, a is on the inside, which is here, but I've got to times it by a -1 because it's a negative a. So my vertex would be, the a would be -1 times 1, which is -1. And my b is on the outside, but it's a positive b, just like up here. So then it's just 5. So this would be -1, that's where the orange comes from, and 5. So if I go to graph this one, my vertex this one time is at -1, 1, 2, 3, 4, 5. All the way up there. Oh, whoopsie. I know, I did something wrong. Back her up, back her up. Hopefully you were yelling at me. I'm supposed to times it by a -1. Why didn't I times it by a -1? I times it by 1. So -1 times -1 is a positive 1. So my vertex should be 1, 5. Whoopsie. Let's get rid of this one. Let's get rid of that. Sorry about that. That's what I get for doing this video at 9 o'clock at night. I'm a little sleepy. All right, so my vertex is going to go at 1. 1, 2, 3, 4, 5. So it starts right here. Now my slope is right in front of my x, the coefficient on the x, and it's 1. So now I just go up 1 over 1, up 1 over 1, up 1, back 1, up 1, back 1. And again, it's reflective. And my v would look something like that. All right, number 6 is f of x equals absolute value of x plus 3, and on the outside plus 1. So now what would my vertex be? A is on the inside, and you have to times it by a -1, Mrs. Smith. And my b is on the outside right here, and you just take it because it's a plus b. So my vertex, hopefully you're saying my vertex would be 3 times -1, which would be -3, and then it would just be 1. So -3, 1 is my vertex. And if I go to graph this, my vertex starts at -3, 1, 2, 3, 1. And now my slope, again, is just a 1, the coefficient on the x. And so that's up 1 over 1, up 1 over 1, up 1, back 1, up 1, back 1. So you don't need to plot all those points if you kind of know the characteristics and things that are going on. Of course, could you plot the points? Absolutely. All right, last one I want to talk about. So one more characteristic I want to show you is number 7. F of x equals negative on the outside, x plus 2, and then on the outside of the absolute value, -1. So first and foremost, my vertex. My vertex is going to be inside, times it by a -1. So my vertex is going to be 2 times -1, which is -2. And then my b is just what's on the outside, and you take it because it's a positive b, so it would just be -1. So you take it for whatever it is, so you don't have to times it by anything. And so my vertex is going to be at a -2, -1. So -2, -1. There's my vertex. Now, I want to talk about this little critter right here. Did you notice that negative on the outside? It has nothing to do with the vertex. It doesn't affect the vertex at all. But this little negative on the outside, makes this, and let's see, maybe I can I find a kind of hot pinkish color? Yeah. Makes the graph open downward. So that little negative on the outside makes it open down. Now my slope is still 1, and I still start at the vertex, still do that like normal, but instead of going up 1 over 1, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and back on the other side, down 1, back 1, down 1, back 1, down 1, back 1. And ladies and gentlemen, those are all the characteristics of absolute value graphs that I want you to know about. Negatives make it open down. The vertex is involved inside and outside. And last but not least, the slope is always the coefficient on the x. So I didn't have to plug in numbers right now. I could kind of do a quick little sketch of absolute value graphs based on knowing some characteristics. All right.